Hello everyone, am I audible? All of you. Please respond me as soon as possible so that I can start the session. Am I audible? Okay. Let's crack GATE ESE with India's largest online learning platform. Get the plus subscription now and start your preparation with India's top educator with unlimited live and the recorded video lecture. Myself Ajay Das. I'm MTech in Computer Science. I have a 8 plus year of teaching experience. And till now I have trained almost 20,000 plus engineering students for the GATE and PSUs. Also work as a freelancer in many reputed institutes of India. Qualified the GATE exam 5 times. Along with that, also qualified Chhattisgarh State Electricity Board exam with the AIR 8. Now, download the Unacademy learning app and start your preparation sitting anywhere, anytime. So, what you will get? This is the major question which always used to arise in everyone's minds. The first thing, you are going to have a daily live classes. Second one is the structure courses. Third one is the live test and quizzes and unlimited access. Learn with the top educators. So I have only mentioned few of the educators who are from the electrical, civil, electronics and mechanical. If you want to explore about the things about the educators, what you can do, you can download the Unacademy learning app and you can check the profile of the educator and their teaching experience and their background history, what kind of result they have produced till now, and accordingly you can decide. And I am sure you will be able to find out that Unacademy is really the best for all kind of competitive exam. So under GATE ESE, as we know, there are various branches like mechanical, electrical, computer science, EC, production, chemical. So, what are the branches for which Unacademy is offering you the preparation for GATE and ESE already mentioned over here? My dear friend, for the GATE ESE, there is only the exam of this GATE. Okay, but for the remaining branches, there is a exam of the ESE also. So Unacademy is offering you two kind of subscription model. One is the plus subscription model. So here it is given as the month wise subscription fees: 1 month, 3 months, 6 month, and 12 month, and 18 month, and 24 month. So if you really want to compete for any kind of competitive exam like the GATE, then I will advise to go for the at least 12 month of subscription, and your fee structure will be 40,250. But once you will apply the code IFA, you will get flat 10% discount. Similarly, if you are looking for the 18 month of subscription, must be if you are in a second year or the third year, and if you are looking for the GATE 2022, in that situation, either you can take the 18 month of subscription or the 24 month of subscription. So for the 18 month of subscription, your fee structure is 38,500, and for 24 month, it will become 44,000. Are you getting my point? But let's see what will be the discounted fees once you will apply the code IFA. So just see over here. So these are the discounted fees. These are the discounted fees. Suppose you are taking a subscription of the 1 year and your fee structure is 40,225, and after applying this code, that is the IFR written over here, your fees will become this. And similarly, once you will apply the code, your fees will become this. And for the 24 month of subscription, your fees will become 49,600 once you will apply the code IFA. So this is all about the plus subscription. Now let's see what is the fee structure of the Iconic and what is the difference between the plus and Iconic. So the fee structure of the Iconic is only applicable for the 12 months and 24 months. You cannot take the 1 month, 2 month or 3 month for the Iconic subscriptions. So if you are taking the 12 month of subscription, your fee structure will become 45,000, and for the 24 month, your fee will become the 60,000. My dear friends, what is the benefit of the Iconic subscription? You can you can choose your personal cost. What? Personal. So this is the advantageous things in the Iconic. So once you will apply the code IFA, you will get again you will get minimum 10% discount in the iconic also. So just see over here the difference between the plus and iconic. So this is the plus and this one is the iconic. Inside the plus, of course, you are getting the India's best educators, interactive live classes, structure courses and PDF, live test and quizzes. But all these things are available in iconic. Let's see what is the extra things which you are going to have in an iconic subscription. You can choose your personal course. So suppose there are uh, 10 number of CS faculty for the gate, so you can choose any one of them as your personal coach who will guide you time to time according to your performance, and they will also clear all your doubts, related doubts, and you can personally will be in touch with him or her. And second one is the personalized test analysis. Your personal coach will do the personalized test analysis and you will be intimated time to time, so that you can find out where you are lacking and you can improve yourself accordingly. Study planner, okay, someone will guide you how to plan your study. And preparatory study material, so you are going to have a study material if you are taking the subscription inside the iconic course. My dear friend, this is the nominal fees. Once you will compare with any one of the online or offline organization, then you will be able to identify this is the one of the most nominal fees that you are going to have. Fine. So my dear friends, am I audible or not? Please tell me, all of you. Let me see. Okay, am I audible? Okay, I'm not able to get any response from your side that whether am I audible or not. Can you tell me whether am I audible or not, all of you? Okay, fine, fine. So these are the things you are going to have in case of iconic subscription. Okay, now let's crack it. My dear friends, our today's discussion topic is the Dijkstra's algorithm and the Bellman Ford algorithm. So let's see how basically Dijkstra's algorithm basically work and where the Dijkstra's algorithm failed to work and what is the need of Bellman Ford. So I'm just considering a example. Okay, I'm just considering a example. So just see over here. Just see over. Dijkstra's. Okay. See, already in case of link state routing, we basically use the concept of the Dijkstra algorithm. So let's see how basically Dijkstra algorithm work. Okay. So it finds shortest path, shortest path to all other nodes rooted at vertex. Okay, this is also known as open source shortest path. It is also known as open source shortest path algorithm. Shortest path. Okay. Just remember this open source shortest path algorithm and take an example. In routing like link state route, link state, okay, we use it, we use straws. So this is the small introduction of Dijktra algorithm. Now let's see how basically Dijktra algorithm work. Okay, just see over here. Just see over here. I'm making a graph. I'm making a directed weighted graph. A, B, this one is C, again D, this one is E, okay, this one is F, okay. The weight is assigned the form of, like, suppose this is the 1, 2, again this one is suppose 7, this one is 3, okay. We can consider this one is 2, again this one is 1, this one is 3, this one is suppose giving as 4, this one is 5, this one is so, okay. So we have to apply the Dijktra algorithm. Now let's see how basically Dijktra algorithm work. See how many nodes are there, or you can say vertices. There are 5 vertices: A, B, C, D, sorry, 6 vertices: A, B, C, D, E, F. And we are assuming this is the root vertex. This is the root vertex, or you can say this is the source vertex. Okay, this is the source vertex. Now since this is the source vertex, so what is the distance of A from A? It will become 0, and initially the distance of all other vertices is taken as infinity. Is taken as infinity. Fine. Now first of all we will access this particular vertex. We will access this particular vertex. So here make another graph according to the accessing. So we have accessed this vertex at the first time. At the first time. So mark it as a what? Mark it as a. So this has been accessed first time. Okay. First time. So once you will access the A, immediately the distance of B and D will be updated. And how you will come to know what is the distance of B and what is the distance of D? By looking upon the table. By looking upon the table which is represented by adjacency matrix. So any graph G, suppose this is the graph G. So any graph G can be represented by either adjacency matrix or adjacency list. So suppose we have represented this particular graph with the help of adjacency matrix. Fine. So looking upon the adjacency matrix, we can easily find out which of the following nodes are there which is directly connected with the vertex A. So there are 2 different vertices B and D. So immediately the distance of vertices B will be updated as 1 and D will be updated as 5, and remaining will remains the infinity. So now out of 1 and 5, which one is minimum? So this is the greedy technique. Already you know this is the greedy technique. And what is the meaning of greedy technique? What is the meaning of greedy technique? So in greedy technique, we always select the minimum age weight. We always select the minimum value. We always select the minimum value. So of course this one is minimum. So we will select this particular is. So next time what will happen, from the A we will access the next vertices, that is the B. That is the B whose weight is 1. So B is accessed in the second point, means second time B will be accessed, and once you will access the B, the distance of C will be updated, yes or no? And what kind of distance we are updating over here? So we know this is the source vertex. So the distance of all other node will be counted from the source vertex, yes or no? So whenever you are accessing the C via B, the distance of C will be calculated with respect to the A. So now you can see over here already the distance of B is 1. And now the distance of C from B is 2. So it will become how much? 1 plus 2, and the remaining will remains as it is. So sorry, already the distance of B is 1 and the distance of C is 2 from B. So it will become 1 plus 2 and the remaining will remains infinity. So what you can write, 3, 5, infinity and infinity. So next time which one will be accessed? So next time out of these two value, which one is minimum? 3 is minimum, so we will access the C. So after the B, we basically access the vertex C. Fine. Now once you will access the C, the distance of F and E will be updated. So what is the distance of F will be updated? Already the distance of C is 3 and from the C the distance of F is 2. So the new distance of F will be updated as 5. Now this 5 is just a new value and this 5 is just a old value. Okay. Now what is the distance of E will be updated? The distance of E will be updated as 10 and this one is just 5. So my dear friends, you can easily analyze, this is the old value and this one is the new value. This one is the new value. So if there is a conflict, between the old and new, which one you have to select, it will be given inside the question. It will be given inside the question, means just note it down. If there is conflict between new and old value, then prefer new one if nothing is given. If nothing is, are you getting my point or not? If nothing is given. So if nothing is given, then what we will do, we will prefer the new root. So of course this is the old value, this is the new value, nothing is given, we will prefer this particular value. So in this situation we are accessing the F. So this has been accessed in a second time, this has been accessed in a third time, and then we are accessing the vertex F. 2, this one will become the, so the vertex F is accessing in fourth time. The vertex F is accessing in fourth time. Just wait. Okay. See. Now once you will access the F, what is the distance of E will become? already the distance of F is 5 and the distance of E from F is 1, that is nothing but 6, and the old distance of E is 10. So what will happen over here? Here we will calculate the minimum of 10 comma the new distance is coming out to be 6. So here the value 10 was via C and this value is coming out from F via F. Got it? So of course out of these two value, which one is minimum? 6, and this one is the 5, which is the which was the old value. Now out of 5 and 6, which one is minimum? 5. Means we are accessing the vertex D. We are accessing the vertex D, and D will be accessed via this distance is 5. So this is accessing in a fifth time. Now at the last moment, whenever you will access the D, the distance of E will remain 6 and it will be accessed at the last moment, and it is accessing via which? Via F. So this is the E and the distance is, got it? So this is nothing but minimum spanning tree. This is nothing but minimum spanning tree rooted at A. Rooted at A, and that all other nodes are situated in a shortest distance. All other nodes are situated in a shortest distance. So my dear friends, see, if you want to go, this was accessed in a fifth time and this was accessed in a sixth time. So if the question will be asked to find out the relaxation order, relaxation, so what will be the relaxation order? Just see over here. First time we have accessed the A, after the A we have accessed the B, and then C, and then F, and after the F we have accessed the D, and after the D we have accessed the, so this one will become the relaxation order. And suppose if the question will be asked to find out distance of, means to find out the minimum distance of E from A, then distance, that is the minimum distance of E from A, it will become 6. So looking upon the spanning tree, you can easily find out the distance will become the 3. Okay, so this one will be the right answer. So in this manner you can easily solve the problem. Now I am giving you one problem related with the GATE 2012. So just to try to solve that particular problem, that is the very interesting problem. See over here. See over here. I am giving you a problem of applying the same concept. You have to find it out. GATE 2000. Just see over here. See. This is the one vertex X. Please draw the diagram. This one is the A, and then this one is the C, this one is the E, and from the E, this one is the G. This is given like this. Okay, this one is 2, 2, then this one is given as 4, 1. Now from the S, the distance of this is the node D. Okay, node D, and this one is the node B, B2. This one is given as 4, 3. This one is given as 7. From the D, we can move to the F. Okay? And from the D, we can move to the G. And from the G, we can also move to the E. This distance is 3. And from the E, we can also move to the E, and this distance is 4. From the E, from the D, we can move to the E. From the C, we can move to the E. And this distance is given as 3. This one is 1. This one is 3. From the T, we can reach to the, this one is 5. So this is the complete diagram. Point, this is the complete diagram. This is the complete. Okay. So what the question is asking, this is the directed graph, and what you have to do, what the question is asking, using Dijktra algorithm, find path from S to T. Find the path from S to T. See, and it is given. It is given if there is a conflict between old and new value. If there is a conflict between old and new root, then prefer old one. Prefer old. This one is given. An option is given as A, S, D, T, E, S, B, D, T, C, S, A, C, D, T, and D, S, A, C, D. Tell me the answer, guys. I'm waiting for your response. Okay. Of course, if you will think about the shortest path, see over here. From S to T, this is one of the path, 7 and 3. 10, again 4, 1, 5, 1, 6, 6 and 4, 10. Again 3 plus 4 plus 3, 10. So there are multiple paths to reach to the vertex T. Means here in this particular graph, there are multiple shortest path, from S to T. But which one will be evaluated using the Dijktra algorithm? That is the question you are asked. Are you getting my point or not? Since there are multiple shortest path, but by using the Dijktra algorithm, you will get only one. So what is that one? Okay, you have to answer that. Any answer? All of you. I am giving you a time span of 2 minutes because it will take some time. See, this is the statement you have to consider. If there is a conflict between old and new root, then prefer the old one. Okay. So suppose if two roots value are same, 5 and 5, then what you have to do? You have to choose the old 5, not the new 5. This is what it is saying. So here what I have told you, if there is a conflict between old and new, and nothing is given, then you have to prefer the new one. But if it is given inside the question that you have to prefer the old one, then you have to follow the instructions which is given inside the question. Any answer, guys? Okay, let me solve it. Okay, let me solve it. So I'm just removing all this part, just removing all this. See, there are vertices S, A, B, C, D, E, F, G, and okay, there are vertices S, A, B, C, D, E, F, G, and then directly T. And we know this is the source vertex. We know this is the source vertex. It is already given. It is already given. S is the source vertex, and that's why we have to find out the distance of T from S. Now, if S is the source vertex, the distance of S will become 0 from S, and the remaining will remains infinity initially. Initially, the remaining will remains infinity. Infinity means till now it has not been accessed. Till now it has not been accessed. Now, first time we will access the S. So as soon as we will access the X, we will look upon the adjacency matrix of this graph, and corresponding to the row of S, what nodes are connected? Node A, D, and F are connected. So what is the distance of node A? This is the 4 will be updated. Distance of B will be updated as 3. Distance of D will be updated as 7. And the remaining will remains. So parallelly, what we are trying to do, we are trying to draw the graph. Okay. See over here. So first of all, we have accessed the X. Now, out of this value 4, 3, and 7, which one is minimum? Of course, this one is minimum. So next time we will access the B. So the next time we will access the vertex B with the A's weight 3. So as soon as we will access the B, what is the new distance of D? See over here. What is the new distance of D? So from the B, the distance is 4, and the distance of B from the S is 3. So the new distance will become again 7. So we are getting two different value. Minimum. One is the 7 via S, and next one is also 7 via B. So out of these two, this one is the old, and this one is we are getting as a. Are you getting my point or not? So old value is already given inside the table is 7. This one is the old value already is there. And what is the new value we are getting from here? We are getting the new value 7 also. So if there is a conflict between old and new, what you have to do? You have to prefer the old one. You have to prefer the old one. means the distance of D will never be updated via B. Got it? The distance of D will never be updated via B. So after the conclusion, what we can write over here? See what I am trying to say. So the distance will remain 7, and just write it down, this 7 from the via S. Okay, this 7 from the via S. So it will become 4 infinity 7 via S, infinity, 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 and S infinity. S means S is the parents. Whenever you will access the node D, S will remains the parent, and that's why I am indicating here, ताकि बाद में आप भूलो नहीं, ठीक है ना? नहीं तो बाद में क्या होगा कि जब आप D एक्सेस करने जाओगे, यू विल थिंक मैं यहाँ से एक्सेस कर लूँ, ठीक है ना? ऐसा ना हो, इसलिए मैंने यहाँ पर पेरेंट इंडिकेट कर दिया. नाउ लेट्स सी, out of 4 and 7, which one is minimum? 4 is the minimum value. So the next time 4 will be accessed, means A will be accessed. So we will access the vertex A. We will access the vertex A. So once we will access the vertex A, new distance of C will be updated as 4 plus 1, 5. 4 plus 1, 5. So the new distance of C will be updated as 5. And this one will remain 7 via S. Okay, now out of 5 and 7, 5 is minimum, so next time we will access the C. Next time we will access the C. So the C will be accessed. As soon as you will access the C, the new distance of E and D will be updated. So what is the new distance of D? 8. Already the distance of C is 5, and distance from C to D is 3. So 5 plus 3 is 8, and already the existing distance is 7, and you need to find out the shortest path. So out of 8 and 7, which one is shortest value? The 7 is the shortest value. So the distance of D will never be updated due to this, but the distance of E will be updated as 5 plus 1, 6. The distance of E will be updated as 6. This will remain 7 via S, and all this remains the. Now out of 7 and 6, this one is minimum, so we will access the E. So what we will do, we will simply access the vertex E, and the distance of E is nothing but 1 from C. Now as soon as you will access the E, distance of G and T will be updated. Distance of G and T will be updated. What will be the distance of G? So already here the distance of E is 6, and from E to G the distance is 2. So the distance of G will be updated as 8, and the distance of T will be updated as 6 and 4, 10. Will be updated as 10. Still the distance of F will remains infinity, and this one will remain 7 via F. So now out of this value, which one is minimum? 7, 8, 10. So this one is minimum. So the next time we will access the vertex D. Of course this is with respect to the vertex D. So we will access the vertex D, and this distance is 7. So as soon as we will access the D, the new distance of F will become how much? So 7 plus 5, 12. So the distance of F will be updated as 12. Now the new distance of T, already from the D we have a connection to the T. So the new distance of T will be updated as 10. Already the distance of D is 7, and distance from D to T is 10. So what will happen over here? Please try to calculate. So here this is the old distance. This is the old distance via which? This is the old distance via E, and you are getting the new distance 10 via E. So this one is the new, and this one is the old. This one is the old. So what I have told you, if there is a conflict between new and old, always prefer the old. So this new distance via D, this new distance via D will never be updated, will never be updated. So this one will never be preferred. So make it as a parent. तो यहाँ पर मैंने E को parent बना दिया है, ठीक है ना। चलिए, तो ये distance अभी भी 10 रहेगा via E, and this distance will become 8. So out of 12, 8 and 10, which one is minimum? My dear friends, 8 is the minimum value. So the next time we will access the G. So just access the G. This distance is 2. So once you will access the G, the new distance of T will be updated. New distance of T will be updated. So up to G, the distance is 8. And from G to T, distance is 3. So 8 plus 3, 11. And already the distance, existing distance is 10. So out of 10 and 11, which one is minimum? 10 is minimum. So the new distance via G will never be updated. So this one will become 12 and 10. This 10 is via E. So the next time, which one will be accessed? We will access the vortex E. We will access the vortex E. So this T will be accessed. This T will be accessed via E with the distance 4. Now, once the T will be accessed, only F will remain. The last time F will be accessed. So definitely the F will be accessed via this distance is 5. So of course, if you are accessing the T, the new distance of F will become how much? 15, and old is 12. So always prefer the old means minimum value. So the 12 is minimum in comparison to the 15. No new route will be updated, and this one will become final MST, that is the minimum spanning tree rooted at. So my dear friends, this spanning tree we are getting with the help of Dijktra algorithm. Now you can see what is the path from S to T. So from S to T, the path will look like this: S, then A, then C, then E, then T. So the path from S to T will look like S, then A, then C, then E, then. So what will be the right answer? What will be the right answer? The right answer will become the option. Got it, everyone? The right answer will become the option B. So in this manner, you can easily solve the problem related with the Dijktra algorithm. Okay, so Dijktra algorithm is nothing but open source shortest path. So this is the S, which is the source node, and what we are trying to do, we are trying to find out the shortest path for all other nodes. So if you want to move to the B, then this one will become the shortest path. If you want to move to the C, this one will become the shortest path. If you want to move to the G from S, this one will become the shortest path. And if you want to move to the T, then this one will become the shortest path. If you want to move to the F, then this one will become the shortest path. Are you getting my point or not? So what I have told you initially, the Dijktra algorithm basically find the shortest path from a given vortex to all other vortices. And that's why we basically implement the concept of the Dijktra algorithm in linked state routing. Because in linked state routing, what we basically do, we basically find out the distance of all other routers from one source router, so that whenever this particular router wants to communicate with any other router, it can follow, the packet can follow the shortest path. Are you getting my point or not? So in the communication purpose, we basically use the Dijktra algorithm in case of linked state routing. Now let's say the drawback of the Dijktra and how we can remove the drawback. let's say the drawback of Dijktra okay. So its main drawback is it is it will never work on the negative age weight. It never works on negative age weight. What does it mean? Please try to understand. Suppose I am considering a graph A, then B. This distance is supposed to, this distance is -4, then C, and this distance is suppose D, okay, 3, and this one is E, again 3, this one is okay, and from here to here it is given as. So my dear friends, what will happen if we will apply the Dijktra algorithm in this graph where S is the source vertex, where S is the source vertex. So first of all we will access the S. Now from the S there are two connecting nodes B and E. I am directly apply the algorithm. So the distance of B from the A will become 2. So this is will be accessed. Now from B there are two nodes connected B, C and E. C and E. So the node which is connected means the C node is connected with the negative age weight. So if the age weight is negative, then here the Dijktra algorithm will fail. The Dijktra algorithm will fail. So the Dijktra algorithm is not able to identify the negative age weight, means it will never process this. Okay, failed means never process this age. So what it will do, from the B the distance of E will be calculated, and distance of E is again 2. So the total distance from A to E via B is 4 and the old distance is 3. So of course the old distance will be preferred because this is the minimum value. So the next time we will access this one. So again once you will access the E, the new distance of D will be updated as 8. So this one will be accessed, and again from the D there is no any vertices is connected. So ultimately the spanning tree will look like this: A, B, then E, and then distance is 5, 3 and 2. So in this situation, vertices C can never be accessed since there is no any positive path. Okay, here vertex C cannot access since there is no any positive is weight. Okay, positive is weight. So to just remove this kind of drawback, we basically moves to the Bellman fold. Okay, so to avoid above drawback, drawback we study about Bellman food. Bellman. So let's see what is the Bellman food algorithm. See, I'm writing few points about the Bellman. So it is similar to the Dijktra algorithm, but it can work in the negative ACE weight. Okay. The first point is it is similar to the Dijktra's algorithm. It is similar to the Dijktra algorithm, but it work on negative ACE weight. Dijktra algorithm नेगेटिव एज वेट पे फेल हो जाता है, उसको एक्सेस नहीं कर पाता है, लेकिन बेलमैन फोर्ड के केस में क्या होगा, ये नेगेटिव एज वेट पे भी काम करेगा. सेकंड पॉइंट जो कि सबसे इंपॉर्टेंट है, जो कि थ्योरेटिकल टाइप के क्वेश्चंस में आपसे पूछे जाते हैं, ठीक है ना, इट कैन नॉट वर्क ऑन नेगेटिव एज वेट. भाई अगर कोई भी साइकिल फॉर्म हो रहा है ग्राफ में, if there is a cycle inside the graph with the negative age weight, then the Bellman-Ford algorithm cannot work. वहां पर ये काम नहीं करेगा. कैसे, इस बात को समझिए. Suppose I am considering graph. This is the A, this is the B. Suppose the distance of A to B is 10. Okay, and this one is C and this one is B. Okay, and we are creating a cycle. Suppose this one is 40. Okay, this one is minus 40 and this one is 30. We are assuming this one is 30. You can assume anything, but we are assuming the 30, and this one is. So once you will apply the Dijktra algorithm, so Dijktra algorithm is not able to process this particular ACE, so from the Dijktra algorithm the relaxation order will be A, B, then C, then D, and the path will be this one and this one. Means from the Dijktra algorithm this kind of path will be this kind of path will be this. Got it? But let's see what will happen if we will apply the Bellman-Ford. If we will apply the Bellman-Ford, see over here, Bellman-Ford algorithm basically work in the negative age weight also. So just see, from A to A the distance is 0 if I am considering this is the source vortex. Now from A to B initially the distance is 10, and from B to C what will be the distance will be covered, 40. So as soon as initially this distance was infinity, but once you have accessed the C, this distance will become how much, 90, because the distance of C is, means distance of C from A is 40, so the distance of D will become the 90. Now as soon as you have accessed the vertices C, again the new distance of B will be updated, and the distance of C itself is 40, and from the C distance of B is minus 40. So what will be the distance of B via C? It will become 40 plus minus 40, so it will become 0. Are you getting my point or not? The distance of B via C will become 40 minus 40, so it will become 0. So once this distance is 0, the distance of C will be updated as 30. If the distance of C is 30, the distance of D will be updated as 80. Are you getting my point or not? All of you, tell me, are you getting my point or not? This distance is updated as 30 and this distance is updated as 40. So if this is the distance and this distance was updated as 0, so if it is the 30, the new distance of B will be updated as 30 plus minus 40. So this one will become the minus 10. So if this is the minus 10, the distance of C will become 20 and distance of D will become, if it is a 20, then 20 plus 70, 50, it will become 70. So this distance will be updated. So if it is a 20, it will become minus 20 and new distance of this will become 10 and this one will become 60 and it will go on. The updation will remains continue. The updation will remains continue and at some point of time, we will be able to realize this is reaching to the minus infinity. These all are reaching to the minus. Got it? These all are reaching to the minus infinity, means the algorithm will filled over here. Algorithm is will filled over here, and that's why I have written this particular statement. It can't work on negative age weight cycle. So if the age weight is negative and it is coming inside the cycle, if it is coming inside the cycle, the Bellman-Ford algorithm is unable to work. So today we have learned two different things. One is the Dijktra algorithm, how the Dijktra algorithm works, and we have seen the Dijktra algorithm is not able to work in the negative age weight, means if inside the directed graph is some of the weight having the some of the ages having the weight negative, then the Dijktra algorithm will never process that particular age, but the remaining age can be processed whose weight is positive. So in this situation, what will happen? Some of the vortices can never be reached from the source vortex. Already we have seen over here. Here we cannot reach to the vortex C from the source vortex S A. Are you getting my point or not? Because the age weight is negative. If the age weight is negative, we are not able to process the negative age weight. So to remove this drawback, we come to the Bellman-Ford. So again, the Bellman-Ford algorithm has some limitation. If there is a cycle and inside the cycle there is a negative age weight, then again the Bellman-Ford will fail to work. So this is the one of the important point that you have to remember with the explanation, so that whenever this kind of question will be asked in your exam, you will be able to answer this kind of question. So my dear friend, this is all about the Bellman-Ford and the Dijktra algorithm. Already we have solved one of the problem related with the GATE 2012. Okay, so I hope you enjoyed this particular session, and in my next session, whenever I will discuss the time complexity of all, like how to calculate the time complexity of Prem's, Kruskal, Dijktra and Bellman-Ford. Okay, so that's all for today, dear friends. So before leaving this session, once again I will tell you, if you are liking my video, then must subscribe this particular channel and never forget to use the code IFA to get minimum 10% discount. Never forget to use the code IFA to get the 10% discount. And to have, if you have any query, concept related query, you can personally contact me on my Telegram number 9264954515. You can press the bell icon button to get all the notification in future, and must put your valuable comment. देखिए ये बहुत ही जरूरी होता है, whatever the things you are feeling after attending the lectures, you have to put the comments, because your one comment will inspire the many other students and they will join this particular session. भाई आपके साथ साथ किसी और का भी भला होना चाहिए, ठीक है ना। तो चलिए, ये फाइनली मैं बोलना चाह रहा था, सब्सक्राइब करना मत भूलिएगा, ठीक है ना। अपने कमेंट्स को जरूर से जरूर लिखिए वीडियो के नीचे एंड बेल आइकन बटन को प्रेस कर दीजिए ताकि आपको आने वाले मेरे हर एक लेक्चर्स का नोटिफिकेशन मिलता रहे। थैंक यू वेरी मच गाइस, टेक केयर, अगेन वी विल मीट एट 10 PM। ओके, आज 10 बजे हम लोग बात करेंगे कंपाइलर डिजाइन से रिलेटेड कुछ स्टैंडर्ड न्यूमेरिकल का, ठीक है ना। बाय, टेक केयर।